In number 4, we're going to step it up again by going to 3 dimensions. I don't know if my 3D picture here is very good. We have a hemisphere with radius 7 feet, and we want to slice to find the volume. So we have the same thing as last time where we can say, okay, well, maybe. Do you know the volume of a sphere? If you do, let me think about it. It's 4/3 pi r cubed. So in this case, and we want to cut that in half because this is only half a sphere, so let's make it 2/3. Oh gosh, I don't know what 7 cubed is off the top of my head, but that will give us something to compare to. I can check it at the end. 7 cubed, 49 times 7, 350-ish, 343. I think it might be 343. Okay, so if we want to slice, I'm going to go ahead and go horizontal again, especially since I did it last time, but you always have your choice. So there's what my slice is going to look like. So now I have to be able to visualize this 3 dimensions. So my slice is no longer a rectangle. Now when I make my little horizontal slice, what I'm getting is basically a not very tall cylinder. The truth is these sides are a little bit slopey, but the idea is that if we make that slice infinitely skinny, that becomes negligible, and we can say, okay, well, the volume of this thing is a pi r squared h. So what we need to know about this thing is what is the radius and what is the height. So I'm going to, since I'm using h already, I'm going to call that a delta y. And then in my picture, I need to say, okay, if delta y is a little vertical distance, then y must measure a vertical distance as well. So we could go from the top or the bottom. I don't really care. Hold on, let me look at my picture. I went from the top, but we've kind of flipped this upside down. So if we wanted to match up with that somewhat, we would go from the bottom. But truly up to you, it doesn't matter. It'll just flip-flop where some additions and subtractions are, but it should give you a completely correct answer. Okay, so here's the other thing that gets a little tricky, is here, back up in our whole picture, there's r, and I need to figure out how to relate r to y. Let's see, extend that down so it looks a little better. And it's going to be another triangle, but if you're having a hard time visualizing this, there is a way that I actually think is kind of handy to turn this into a 2D picture. So imagine taking what we're looking at and just slicing vertically. So like we take a knife and we just chop right down the middle, and we look at the cross section, and it now just looks like the half circle that we had in the last problem. And our strip just looks like our rectangle that we had in the last problem. So now we're saying, okay, r is our w over 2 that we had before. Here's y, and just like before, the key piece of information is we know that that radius is 7. So we can say that 49 is equal to r squared plus y squared. And what am I trying to do? I'm trying to get everything in terms of y, so I'm going to solve for r. So we're going to say the square root of 49 minus y squared equals r. No one is going to try and split that root up over subtraction. That absolutely does not work. That is a fatal algebra error. No one is allowed to do it. Okay, so back up to our volume of our slice. We can say that our single slice has volume equal to pi times the radius squared, which is really nice because it knocks out that square root. So technically at this point I should still have a y sub I. That's some specific y value within my slice. And then the h is a delta y. So we are going to want to add all of those up. So we're going to integrate pi times 49 minus y squared dy. Now that we're basically hitting every single y, we don't put that yi to represent that specific y that we have to choose either at the top or the bottom or the middle or somewhere in between. And then we need to, since y is vertical, we need to start at the bottom of the sphere when y equals 0. And we stop slicing when we hit the top of the sphere when y equals 7. So this one is going to be much easier to integrate than the last one. I don't have to get my pi involved by doing trig substitution, it's already involved because my slice was a cylinder. So I'm just going to say that this equals pi times 49y minus y cubed over 3. And then evaluate from 0 to 7. Okay, so I have pi times 49 times 7. Okay, I'm going to actually double check my arithmetic here. I think I claimed it was 343. So 49 times 7. 9 times 7 is 63. 7 times 4 is 28. 29, 30, 31, 32, 33, 34. And I think I didn't lie to you. Okay, so this is 343 minus 343 over 3. So again, 49 times 7 is the same as 7 times 7 times 7, which means we're taking 1 343 minus a third of a 343. We have 2/3 of a 343, which even without trying to make that into anything else, I think does match up with what we said above, 2/3 of pi times 7 cubed. So there is our answer via slicing, and it does agree with what formulas say it should agree with. Thanks for watching.